Hi, and welcome to the last presentation that we have today. Let's talk about terminals. It's a bit of a bizarre title perhaps, but FyneTerm is a project that I've been wanting to do for quite some time. Terminal emulators are kind of cool. There's such a variety of them, and from the functional to the beautiful, very specific to one purpose, to the completely broad, could be anything. So I thought that there was an opportunity perhaps to look at one of our own. But why build another terminal emulator? Well, I mean, it's an interesting challenge. The biggest, most difficult software to build is always the best thing to look for, right? I quite like to see how some terminal emulators are put together, and I'd love to contribute to them, but I don't know, the code is just a little bit of a challenge. So given that we're rewriting, a toolkit from scratch so that it can be well designed, put together, there's probably a good chance to see how that toolkit adapts to a big problem like this, a chance to stretch what it was already capable of. So yeah, let's start with a clean code base. Let's have something that's way more maintainable. Let's have tests all the way down, and not just check that theme files load correctly or that a code is handled in the right way, but that really every aspect of it is well tested. We can do that with a modern framework like Fyne. Now, I think that a lot of default terminals, not pointing any fingers at all, aren't all that pretty. They're functional, they're utilitarian type pieces of software that get the job done. And I don't know, I think with retina screens and all of the high res image manipulation stuff we have around us, it would be great if we could do something in the terminal that looked as good. Lofty ambitions, but it was an idea. And if it could work consistently across platforms, we would be delivering on the same ideas and promises that the Fyne toolkit has, that something that's built once is going to work across all of the supported target platforms. And we have a widget-based toolkit system here. We've talked about extensible widgets and pluggable infrastructure before. So complex applications, maybe an IDE, a developer tool of some sort, might want to embed their own terminal. I know that I've wanted to in the past for previous projects. So if we could provide a terminal widget, that would be pretty cool. So the best test application would be a terminal itself. Yeah. And also, I spend most of my day on the Fyne desk in the Linux system, working and interacting with a huge variety of programs. And other frameworks don't adapt in the same way to the screens. They don't have matching themes. It's really tricky to get that. And I thought, well, this would be a really nice addition. So how exactly is Fyne or Go a good fit for a project like that? Well, we're looking to build good quality, well-tested software. I can't think of a language better than Go that can put that kind of rigor behind something that is still easy to develop, quick to learn, with a really great community. It's a modern language, but it's creating native applications, so we've got the best of both worlds there, I think. String handling and concurrency, they are just light years ahead of C and other languages, which is where most terminal code is currently written. There's modern adaptations of that language, but they're still struggling with some of the same issues under the hood. So again, Go works really nicely for this type of project. We're passing lots of data through, we're doing string processing, and we've got user and backend systems trying to interact with the same output. This was not really possible before the text grid widget that was introduced in 1.3. Not much of a coincidence there, but we wanted to be able to support complex applications, whether it's a code editor or a terminal. We needed something that was more substantial to be able to show the types of highlights and intricate detail inside the text, where you've got each character is going to be looking different to the one next to it. So the text grid widget provides us that ability. Fyne is able to take care of the graphics handling, which is fantastic. It will open the window and present the canvas on any system. So really all we have to do is the terminal emulation. We work on the details of what's coming in, going out, the state, and ask Fyne to present it for us. So really a lot of the cross-platform stuff is taken care of, except perhaps the terminal part that will, the connecting to the virtual terminal, which we'll talk about a little bit later on. Thankfully, Go as an ecosystem has some really great libraries, and they're mostly open source, readily available and well documented as well. I found this library, which will allow you to connect to Unix virtual terminals, is so easy to use. It allows us to work on Linux and on macOS just out of the box. There's some Windows work underway that maybe has a little bit more work to go, and we're probably going to have to look for other libraries to present shells in other systems where it doesn't have the same concept of virtual terminals. So you might be loading an emulator instead of a terminal connection through to the operating system. But that was a really great start, and that can't thank the guys from that project enough. So to achieve this project, what did we do? Okay, so the project, first of all, we needed a type, a top level type that was going to be the widget, the thing that would be embedded in our terminal application and in other applications. Not particularly imaginatively, but we called it terminal. This implements the Fyne widget interface, and it embeds a text grid, which means that rather than extending text grid, so all we could present was a grid of text, we embedded it so that we can handle other elements such as cursors and overlays. Anyhow, any application that wants to use this calls new terminal, which gives them the widget. They put the widget into their application, and when they want to start running the process of communicating with a virtual terminal behind the scenes, they call term.run. So, I mean, 2 lines of code to embed a terminal in your application. I think that's pretty decent. I'm happy with that. If you were to look at the code for this terminal package, we have split it into a few different files. Terminal, I mean, that's the part above there. It's the main API, a couple of utility functions, so that somebody who's embedding a terminal isn't just getting an area that they have to then hand over completely. They can actually interact with it. There's some functionality in there that would probably be useful if you're wanting to do something smarter than simply embed that widget and forget about it. The input output is one section. This is I guess you might call it the low level stuff. Bytes in, bytes out. It's connecting through to a virtual terminal. You've got the input is the user, it's typing things in, and we need to communicate that out as well as update the display. And output is what the virtual terminal or the command it's running is going to want to present to the screen, so we would then receive that and update the display as well. Render really takes care of the details of what's going to be displayed. It's positioning that text grid and sizing it appropriately. It's managing the cursor and overlays and other stuff that might appear on or around the text grid. Render really is a widget renderer like you would expect with any widget, but we kept it separate because the code is really quite different, and there was a move potentially down the road in the project to separate widgets from renderers, because one is the state and the renderer is you know, in charge of how it looks. The two really shouldn't be very connected, so we split them apart here. And then escape codes. We need to handle a lot of different functionality that comes through the virtual terminal, and in the bytes we need to look for special characters. So that part of the code is going to peek at all of the data coming through. It's going to look for specific codes or symbols that start an escape code, of which there are 2 or 3. And then it looks for the next one to see if it understands what code might be starting. And at that point, it might do something like move the cursor up or insert a specific character. Or it might be introducing a more complex sequence like a color. And so the parser needs to look a little bit more at the data that's coming in as the stream and see if it understands the rest of it, package it up, and that data is passed into an escape code handler, which might then do a color code lookup, a cursor style, and then it feeds this information back to the terminal API through testable methods. So these are quite separate and could be well tested individually. And then if you look at the code, we have an entirely separate package, the command FyneTerm folder, which is the actual app. It embeds a terminal type so that it can essentially fill the window with that terminal. And just for a little bit of prettiness that I think is suitable for the terminal application, but perhaps not the embedded mode that other applications might look for. It puts a little background behind, other things might appear as well. And it's going to handle certain shortcuts like exiting the terminal for one thing. Probably isn't something that you want to do if the widget has been specifically embedded in another application. So what does that get us? Well, pretty much a fully functioning terminal application. This is the current version, or in fact, probably a couple of bug fixes ago. The color scheme is a little bit rudimentary, and we're working on that, but that's showing a full bash terminal with certain commands embedded in. You can see that we have things like the alignment of text set up appropriately, color codes, cursors are being handled, although amusingly it's not actually shown there. The window probably wasn't focused when the screenshot was taken. And I quite like the background under there. Subtle but classy. Folk might want to switch that out at some point, so we'll have to add the configuration. So that's what we got. I think it looks pretty decent. The code is quite nice and tidy, but it was not the easiest of journeys. There were a fair number of challenges that had to be overcome. It is really hard to build a cross-platform application when a Unix terminal is the core of what you're doing. The virtual terminal is an operating system provided channel for managing data through to this concept of a terminal. So on Unix it's great. On Mac OS it works. On some other systems it may be possible to do something similar, but like I said before, it means that it's not fully working on Windows, and on mobile we haven't really figured out how to provide that same functionality. But this is an early project, and I've no doubt but that we'll get there with some brainwaves or more contributions. I'm sure that it truly can be a cross-platform terminal, looking good on all devices. One thing that was a little bit of a graphical challenge was min size. One of the things I think that people find a little bit strange when they come to the Fyne toolkit is that min size is very important. It's the default size for widgets unless you give them more space. We want to make sure that applications are aware of what's visible, how big they need to be to fit the content, and this can be an area of challenge if you're not used to it. Now, the challenge that we had here is that a terminal wants to fill the available space. We saw in the demo there that the text is right aligned. So if you use the standard minimum size, then the window can't get any smaller because we can't go below min size. If we get bigger, it will expand quite correctly, but then we'll be at a bigger size that can't get smaller. So the way that we embedded this text grid, we actually had to override that the widget that embeds it has its own understanding of what minimum size is, which is really kind of small. And it is adjusting the text grid at the background. The min size for the text grid is really metadata, and we can choose to ignore it or to use it. But to the canvas, to the window, we're saying actually the min size is far smaller than the space required for the text, because when the window does get smaller, we will then shuffle the content, the text grid, and make sure that the text in the terminal is shuffled down accordingly. Which leads to the next challenge. We had the graphical output, which was a set of text cells with a specific number of rows and columns, and we have cursor position, which you can clearly see. However, a virtual terminal also has understanding of size. You need to communicate to it how many rows and columns it has. Things like your top application is going to be as big as is available. So the terminal knows certain things about its output. And so just by updating our graphical representation doesn't actually change things. We had to coordinate those. And the cursor was a similar challenge. Moving around a cursor on the front end needs to reflect back so that certain operations occur in the appropriate memory space. We have had a bit of a challenge with performance as well. If you make your terminal really big, it has many thousands of objects visible, because every piece of text and every background to a piece of text is a separate graphical object. Now these are cached, and if you aren't making massive changes to the content, it's not going to be a problem. However, when you refresh a widget, the default thing that it does is refresh all of the child items inside it, because we're not specific about what changed. So we had to work a little bit with the text grid so that you could refresh only one character at a time, and then inside the text component it's able to realize, right, well, we just need to refresh the textures for 2 components there, not for thousands of them. That's a work in progress actually, so the performance will improve vastly, although it is actually pretty decent at the moment. The overhead for the graphics processing varies platform to platform, so on macOS it's a little bit sluggish, but on a Linux system it seems pretty speedy. Probably wouldn't recommend running that on a Raspberry Pi right now though, until we've addressed some of those issues. And the last challenge was escape codes. They're really complex. There's a huge amount of documentation about escape codes. There's ASCII codes and ANSI codes, and specific for certain terminals and certain terminal emulators. There's standards and there's extended standards, and there's not particularly standard but very common areas. And sometimes this documentation conflicts. So our tests are very useful. It means that we are validating the behavior, but sometimes we're validating the wrong behavior because the documentation wasn't very clear. So it is actually something where you have to run the terminal, load your favorite commands and see how they behave. Bash was pretty straightforward, the very clear standard codes that it utilizes, and ZSH was great to get started. And then I plugged in one of the more complex ZSH themes that uses some extended codes that aren't so common, and there are clear areas that we could extend that support to give a more complete output. And also there are small sets of standard color codes, which you saw in the screenshot there, but actually there are hundreds of different codes that could be supported. So we've got to identify what a color code is and then figure out whether we understand what that number of code for color represents. Some of them we match quite nicely, others we need to look more into, and then extended code sets can indicate more complex interpretations of the same numbers. So you could have a code that says invert the next code, and then that color code has to be inverted. So it's a more complex state engine than perhaps was realized when the escape code work was first put together. But those challenges have mostly been overcome. The terminal is working well, but there's so much more that I think that we could do, or that I would love to do with this project. Firstly, scrolling. It is currently resizable, but in the scrollback sense, a fixed terminal. If something disappears off the top, then it's gone. Handling scrolling efficiently with huge amounts of data, graphical elements, is actually something closely related to work going on in 2.0. So it's possible that we might not be able to get a good scrolling implementation until that release has come a little bit closer. It's probably a little bit too complex to solve just in the application. Like I mentioned before, a full color set would be pretty good. Some of the terminal themes that you see are really gorgeous when they get their colors blended nicely, a little bit beyond the 16 color version terminal that I have set up at the moment. User preferences, it's got to be something we put in there. The framework is there. The Fyne Preferences API could handle it all for us. And whether we include themes in the way that themes are handled for Fyne, possibly not, or whether it is local files or resources, user preferences, haven't really figured it out. But to be able to specify that would be cool. Standard set of colors, absolutely, but if everything on your system is set up as solarized dark, for example, or if you have a custom theme for FyneDesk and all of your Fyne applications, then maybe you want to match that in your terminal color set as well. So I'd love to see that added. Optimizations. There is a lot to do here to make it performant across lots of different systems. I think the majority of the work is in, well, half of the work probably is in TextGrid, and we're working through that at the moment. And the other half is probably with being smarter about the terminal output coming through the virtual terminal connection. It's kind of being dumped to screen and then forgotten about, but if we were to buffer it in text, probably could do much smarter change handling so that we only ask the screen to redraw the stuff that really has changed since the last frame. I think that'll really help. And then do need to add support for some of the less common escape codes. Not all colors. There are certain things about copy-paste handling and specific terminal functionality that some commands look for. It may not be necessary to support them all, but we should at least identify them all and know whether they need to be implemented or not. For one thing, it keeps the errors off the command line because we currently mark a code that we found that didn't make any sense. We should definitely respect all of those ones we find. And it would be really nice to do something cool with some smart content, not just text-based output, but to do something like graphical previews or more interactive items, hyperlinks or whatever. There's some really great examples like this. Terminology is a project that I love. Part of the Enlightenment project, and they have done amazing things like dropping graphical files inline when you ls. Given that we are backing to a graphical canvas, we could do a huge amount of cool things there. I think that it's really the ideas, the innovation there, what can we do, is the complex part. Rendering it, putting it out to screen should be pretty straightforward with a solid toolkit underneath this. Well, I hope that's interesting. If you're on Linux, you should totally check out the FyneTerm project right now. If you're on Mac, you could look at it and help us out with some of the optimizations there. It might not be something that you use every day at the moment, but it's getting close. Thanks for listening. This has been really interesting to run through. I'm very excited to share it with you.